Hello everyone, welcome to today's class. Today we are going to look at real-life application of modular arithmetic. Now when we say real-life application of modular arithmetic, we are talking about where we can apply modular arithmetic in our real-life situations. So let us look at some of the examples. Let's take for instance that we schedule a class, or we had our first class by, let's say, 6 p.m. Okay, and we need to have the next class in next 30 hours or next 100 hours. What time will it be? Talking about 6 p.m. is when we have had the last class. Then the next class is going to be in 100 hours time. Okay, in 100 hours time. So what time would that be? You can use modular arithmetic to solve such problem. Okay, so we are going to solve some examples to see how we can actually apply modular arithmetic in real life situations. So look at the first example we have here. If today is Thursday, on what day will be 560 days from now? Now take days of the week as Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so the point that you are starting, you take it as 0. Remember, if we have modulo, let's say modulo 8, we have the digit under modulo 8 as 0, 1, continue to what? 7. Okay, so that's how we are going to start. The first day or the day we started is regarded as what? 0, because that 0 is always the first digit in modular arithmetic. Okay, so in this case now, for this question, on Thursday, they say if today is Thursday, so Thursday is going to be what? 0, then Friday 1, Saturday 2, Sunday 3, Monday 4, Thursday 5, and Wednesday 6. Okay, now having that in mind, all we need to do is to take our modulo of 560 in modulo 7. Why do we take it in modulo 7? Because the days of the week runs out after every 7 days. So after every 7 days, it starts again. After every 7 days, it starts afresh. So we're going to take that modulo in modulo 7. If it's time, when I introduce this topic, if it's about time, you can take your modulo in modulo 24. If it's weeks, let's say weeks in a year, or let's say months, for months, you take it in modulo 12, because after every 12 months, the cycle start up all over again. Okay, so after every 7 days, the days start up again. So after, if you move from Sunday to Saturday, you have total of 7 days. So you take your modulo in modulo 7. So this problem now, that will give us 560 in modulo 7. In modulo 7 will give us 7 times 80 plus 0. So that will give us 0 modulo 7. So which day represents 0 there is going to give us Thursday. Okay, so of course it's a word problem, so you don't just get 0 and stop there. You need to conclude. You need to tell us what you have done. So 50 days from now will be Thursday, because we have 0, and 70 times 80 will give us 560. So there's no number remaining, which is 0, and the day that is being represented as 0 is on Thursday. Okay, so let us take another question, probably a question on time. Let's see how that will look like. So this next example we have here is about time. A drug was given to Mrs. Ola to be taken in every 70 hours. If she took the first one by 7 a.m., what time will she take the next one? Now, unlike a problem on days that we can easily write out our days, starting from the day the program or the event starts as 0, then end in the seventh day, which is represented as digit 6. Of course, modulo 7 will give you 0 to what? 6. Now, in hours, we don't expect to start writing all the time. Let's say 7 a.m., 8 a.m., and all that. Okay. How else can you do that without all this? Okay. Without all this, how else can we do that? If you have your modulo, you add it to the initial days. For example, what we did now, which is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So we say 0, 1, 2, 3, 4, 5, 6. So for instance, I solve my problem and I get 2 modulo 7. All I need to do is to add 2 days to the starting day. So this is the starting day. So I'll add 2 days. That 2 days will give me Friday and what? Saturday. So if I have 3 modulo 7, I will count 3 after the starting day. Okay, after the starting day will give me the next day. So even if I do not write this, I can as well get my value without describing this. But I did that in order for you to see what is actually happening there. Okay, so when I take my modulo, let's say for example I get modulo 12 modulo 24, or I have 8 modulo 24. All I need to do is to count 8 hours after the 7 a.m. Okay, so that's how we do that. So let's look at what we are going to have here. So we are going to take our modulo in modulo. Yes, this is another place. Some textbook, if you check, you might be seeing modulo 12, while some be writing modulo 24. I prefer to write modulo 24. Why? Is because if I do modulo 12, remember we have 7 a.m. and we have 7 p.m. But if I do modulo 24, I know that after 12, if I have 13, that's 1. If I have 15, that's 3. If I have 19, that's 7 p.m. Okay, so I take my modulo in modulo 24. Whenever I have problem to deal with time, I take my modulo in modulo 24. Okay, because you will not be asked to use any particular modulo. What you'll be asked is to find the time in the next so number of hours. Now we have 70, so I'm going to take 70 in modulo 24. So 70 in modulo 24, that will give us, so 24 times 2 will give us 48. 48 plus 22 will give us 70. So we have 22. So that will give us 22 in modulo 24. So that, like what I said before, now I have 22. All I need to ask myself, 7 plus 2, if I add 22 hours from 7 a.m., what time will it be? That's just like removing 2 hours from 7 a.m. Okay, so if I add 22 hours to 7 a.m., that will give us 5 a.m. Okay, so I will conclude, therefore 7 a.m. plus 22 hours, that will give us 5 a.m. Hence, the time she will take the next drug is by 5 a.m. Okay, so by 5 a.m. Of course, that's the next 3 days, because 24 hours first day, another 24 hours second day. So the third day now, that's when she's going to take that particular drug. Okay, so this is how to deal with time. So like I said before, whenever I'm solving a problem on time, I make use of 24 hours. Okay, so that any number that I have, it will be easier for me to solve. Okay, so let us look at another question and see uh, the dimension, okay, and see how whether there will be difference on what we have been doing or whether is going to still be the same thing that is going on. A man visits his company every 6 days. If his current visit is Thursday, what day of the week will be his sixth visit? Okay, or will his sixth visit be? Now, in this kind of question, we need to be careful. Okay, what I mean being careful is that there's difference between his sixth visit and his next sixth visit. Okay, so let me write it down. His sixth visit, his next sixth visit. Okay, so look at these two things here. His sixth visit and his next sixth visit. Now, if somebody, let's say you visit a particular place, okay, and you are already there, that counts as one. So your sixth visit now is going to be the next 5 times you are coming. But in this second one, they say that his next six visits. So his next six visits simply means that if you include the one that he have visited as the one that he's presently at, that means it should be total of 7. Okay. So in this question now, you will notice that he's currently there. He said that if his current visit is on Thursday, okay, so he currently visited on Thursday, what day of the week will his sixth visit be? That means this current visit here is his first visit. So we are now looking for his what? Sixth visit. Sixth visit in the sense that the sixth visit will not be in the next 5 visits. Okay, so what are we going to do? Every 6 days he visits. So he's there now. So in the next 6 days, he will go again. The next 6 days, he will go again. So if you calculate the number of time remaining, if we count this one as first, the number of time of visits that is remaining to get to sixth is what? Is 5 visits. Okay, so in such case, all we need to do is multiply that 5 times the number of days per visit. It will take per visit. So it will take 6 days to visit. That means we are going to have 5 times 6, which is equals to 30. So we are going to do 30 in modulo 7. Why? Because we are dealing with what? Days of the week. So I'm not going to write the Monday, Tuesday, Wednesday, Thursday. Let us just solve and see how we can use our value without describing Monday, Tuesday, Wednesday in our answer. So 30 in modulo 7 will give us 7 times 4, which is 28, plus 2. So that will give us 2 modulo 7. So 2 modulo 7, how can we solve? Remember, the day of the current visit will be regarded as what? 0. That's the first digit in your modular arithmetic integers. Okay, so all you need to do is add 2 to it. So add 2 days after Thursday. What do you have? Friday and what? Saturday. Therefore, Thursday plus 2 days will give us what? Saturday. Therefore, his sixth visit will be on Saturday. Okay, so we can even use the modular arithmetic to know the week. Okay, from how can we know the week? Remember, see this. 7 times 4 means that we have exhausted 4 weeks. So we are in the 5th week now. Okay, So he will visit his next visit, his sixth visit is going to be on Thursday, the fifth week or the next fifth week. Okay, of course, if you include this one, it will be the sixth week. Okay, so without including the day that he's visited, which is the present day, is on the fifth week that is going to complete his what sixth visit to the company. Okay, so I hope this real life application. Okay, let's solve one more problem that have to do with uh, his next or next 5 days, next 4 days time. Okay, let's have example number 5. So look at this question. It says that if today is Tuesday and it is the Eke day and the Igbo market days, on what day will be the next 10 Eke days? Next 10 Eke days. Okay? Or next 10 Eke day. Okay? So in this question, unlike the one we solved previously, this particular day that is Eke market day is not included in the next 10. Okay, so we are going to calculate the next 10 excluding this present day that is what the Eke day. Okay, so what are we going to do there? In Igbo land, the market days is in every 4 days. So if we are looking for next 10 days, that we are looking for next 40 days. So what are we going to do? We take our modulo. So 4 times 10, which is equals to 40, and modulo 7. Of course, that's number of days. So that will give us 7 times 5, which is 35 plus 5. Okay, that will give us 5 modulo 7. Now, if today is Thursday, therefore, okay, now, if today is Tuesday, therefore, Tuesday plus 5 days. What would that give you? Tuesday, if today is Tuesday, then plus 5 days. So you have Wednesday, Thursday, Friday, Saturday, Sunday. So that will give you on Sunday. Therefore, the next 10 will be on Sunday. So it's also easy for you to know which week. Okay, that's after the 5th week. So it will be on Sunday, the 6th week, because this is where we are. Sunday, we have 5 weeks already gone. So this is the 6th week. So it will be on Sunday, the 6th week. Okay, so that's how to solve problems or real life application problems on modular arithmetic. So the next thing we are going to do now is to solve problem that relates to algebra in modular arithmetic. Okay, so look at the problem we have, okay, that relates to algebra. 2m plus 4 equals to 5 in modulo 7. This is a problem that looks like when we are doing division, okay? So when we are doing division, we do something like this. It's very simple. All I need to do is to highlight the integers in modulo 7. So modulo 7 will give us 0, 1, 2, 3, 4, 5, 6, yes. Okay, so the next thing now is that I will pick all these values and replace it as n to find out which one will give us 5 in modulo 7. So we do that. 2 in 0 plus 4, that will give us 4. 2 in 1 plus 4, that will give us 6. Remember, in modulo 7. Okay, 2 in 2 plus 4, that will give us 8. And 8 in modulo 7 will give us 1. 2 in 3 plus 4, this one will give us 6. 6 plus 4, that will give us 10. 10 in modulo 7, that will give us 3. 2 in 4 plus 4. 2 in 4 is 8. 8 plus 4, that will give us 12. 12 in modulo 7, that will give us 5. So let me write the number first. 2 in 5 plus 4, that will give us 14. 14 in modulo 7, that will give us 0. 2 in 6 plus 4, that will give us 12 plus 4, 16. 16 in modulo 7, that will give us 4. So the only one that gave us 5 in modulo 7 is this. Therefore, what value of n do we put there? 4. N equals to 4. As simple as that. Okay. Now, the next question we are going to solve on algebra is a question that relates to modular arithmetic and binary operation. So we are going to look at problem on modular arithmetic that combines with what? Binary operation. Number 2 question, the operation is defined on the set T equals to 2, 3, 5, 7 by x binary y equals to, so you have been given the rule of combination to combine your x and your y in modulo 8. They ask you to construct a table for the modular arithmetic, and you are not asked to use the table to solve some of the problems given below. Okay. Now, the first thing to do is to construct your table. You are given a set. That means you don't just pick any number in modulo 8. So you have to make use of the numbers given to you in modulo 8. Now, sometimes a question will be given to you without giving you a certain set of numbers. For example, you might be asked to construct a table of multiplication in modulo 3. If I'm asked to construct a table of multiplication in modulo 3, this is what I will do. I'll have my multiplication sign 0, 1, 2, because 0, 1, 2 are the numbers in modulo 3. So all I need to do is to find the value that will be inside these boxes. Okay, so this is multiplication in modulo 3. Okay, but in this question, they did not ask us to find the multiplication table in a certain modulo. Rather, they ask us to find the table obeying this rule of combination. Okay, so here we are going to let one part to be x and the other side to be what? Y. Then we now carry out this rule of combination to get the numbers that will fit in the boxes. Okay, so let us do that and see what we are going to have. So you can see our numbers 2, 3, 5, and 7, 2, 3, 5, and 7. So we can take this place to be our x and take this place to be our y. Then, if I pick 2 binary 2, I will get, obeying this rule of combination, I will get the value and put it here. So you can see that we have a lot of boxes here. So I'm going to show you how to do it maybe for the first row. Then after that, I'm going to fill it in so that we can be able to answer our questions. Okay. Now, what to do there is, first one is 2 binary 2. So we have 2 binary 2. You have to obey the rule of combination. Okay. The rule of combination, which is x plus y plus xy. So x plus y plus x times y, because xy means x times y. So that will give us 4 plus 4, which is equals to 8. But remember, we are carrying out this operation in modulo 8. So 8 in modulo 8 will give you what? 0. Okay, so you have what? 0 here. So this will give us 0 in modulo 8. So we'll go to the next one, 2 binary 3. That will give us 2 plus 3 plus 2 times 3. That will give us, these two will give us 5, plus these two will give us 6. So that will give us what? 11. 11 in modulo 8. So we are doing this multiplication in modulo 8. So 11 in modulo 8 will give us 3 modulo 8. So this one will give us what? 3. Then the next one is 2 binary 5. So we have 2 binary 5. That will give us 2 plus 5 plus 2 times 5. So what do we have here? 7 plus 10, which is equals to 17. And 17 in modulo 8 will give us 1 modulo 8. So we have 1 here. So the next one is 2 binary 7. So we'll do the same thing. 2 binary 7 equals to 2 plus 7 plus 2 times 7. So that will give us 9 plus 2 times 7, 14. So that will give us 23. Okay. 23 will give us 7 modulo 8. Okay. So we'll write our 7. So this is how you are going to use and fill it in. 3 binary 2, you do the same thing. 3 binary 2, that's 3 plus 2 plus 3 times 2, like that. Okay. Sorry, here should be 2. So that's the way you should do that and fill up the table. So I'm going to do that now and continue with the next question. So I hope that you are done filling yours now. So we are done with the A part of the question. So let us go to B part. The B part says that 2 binary, 5 binary, 7. So the first thing I will do is to find the value of the bracket, which is 5 binary 7. So 5 binary 7 will give me this 5, this 7. So if I follow it, I'll have 7. So 2 binary 7, what would that give me? 2 binary 7 will give me 7. Okay, so that's the answer for the first one. That's the BI. Then II, we are looking for N. 2 binary N, that will give us 5 binary 7. So 2 binary N. So which number will I combine with 2 to get the same thing that 5 will combine with 7? So 5 combined with 7 is 7. So 2 binary N to give us 7. So what will I combine with 2 to get 7? So that will give us what? That will give us 7. So therefore, since 2 binary 7 will give us 7, therefore N equals to 7. So we have gotten our answer and we have finished up with the questions. Okay. All right. So we have done a lot already on modular arithmetic. So do well to like the video, subscribe, and share the video. Okay. See you in the next class. Thank you.